Continuation to our practical sessions, we did the basics of geological mapping, and we have seen how the geological maps can be interpreted. And today's session, we are going to discuss about the situation where the rock strata in the area is inclined in nature. So, in contrast to the horizontal stratified strata, when it comes to the inclined stratified data strata region, the geological map or the appearance of the geological map slightly varies. Like if you remember, the horizontally stratified strata were there, then the geological map we observed that the lithological contacts and the contours are running parallel. So that is the general characteristics of the contour and lithology. But in the case when we talk about an inclined stratified region, by saying that I mean this is a hilly terrain, where in that hilly terrain there are two different or three different rock types. So one rock which is composed of the hill in the region is showing an inclined nature. Okay, so this is the rock strata. Now what will happen if the rock strata is inclined in nature? How the geological map will appear? So from the descriptions or the preparations of geological map we discussed in the previous session, we have seen that in the case of a geological strata, or in the case of an inclined geological strata, the lithological contacts on a geological map will cross cut the contours. Okay, but how this will cross cut, that is what slightly we are going to see in depth in this session. Just for an example, if I consider this region, so this is the hilly terrain. Now just imagine I'm going to cut this region or this hill at a particular height of around 130 meters, for example. So what will happen? I cut that region, and if I see it from the top, what I'm going to see in this case is completely one particular rock type that is exposed here, this rock type, because this rock type is not still cut, it is still further below the height. So what I will see, and if I make a contour of that or a lithological contour of that, so this is what I'm going to see, and that will appear something like this in the map section or in the two-dimensional view. I'm going to continue this process. What I'm going to do is that I'm going to cut this hill further down. For that I'm going to cut the hill at a height of 80 meters. Now if I see from the top, what I will see, because it is now cutting both the rock types, this rock type is also cutting, this rock type is also cutting. So somewhere in this rock type I will see half portion of this. For example, if I write it is rock type A and this rock type B, I'll see rock type A and rock type B from the top when I see. So this is why I will when I take this lithological contact at this height. What is the height at here? I take it is 80 meters. So that 80 meters will see something like this. So if I consider both this 130 meters and 80 meters together, so it is how the contour and the lithology is going to appear. So 80 meter, this is 130 meter contour where I am cutting, this is 80 meter contour where I am cutting. There is one more. If I go for to cut the height, cut the hill at 30 meter, what will happen? This contact what I see here will shift to somewhere here, or it will appear something like this. It is shifting further. So earlier the contact was here, now the contact is shifting further. Why is it happening? Because the rock is inclined. So if I cut the rock at this height, this is the contact when I see. When I cut the rock at this side, this is the contact between A and B I will see. Simple logic, because the rocks are inclined. If I go further down and down, the rocks contact where it is intersecting, that will move a little horizontally shift. So if I see this in the geological map, this is something how I am going to see. If I see the 80 meter, 130 meter and 30 meter, all the contours together, so I'm going to get something like this. I see it in general. These intersections I'm not going to see. Rather, what I will see something like this, which cut the rock. If I am assuming that the entire region is hill. Okay, so this area I need to fill with the with this, and this area I need to fill with this rock type, because that is a sloping part, it is not cut or vertically. So that sloping part will show me something like this. Okay, or in other way, if I see a simple geological map like this, these are the contours, and if I see the lithological contact which is seen on this map, that is having a characteristic something like this. What is this represents? The yellow line that represents the contact between rock type A and rock type B. So if I start climbing from this part, when I reach this height, I will get the change of rock type, and after I move further, I will get the get another rock type. So if I climb from here, I will get this contact at much lower level than if I continue to walk to the upper height. So this is what the general concept or the idea of the lithological contact, how we see in a geological map. So here when we see these points, what are these points? These points are the places where this lithological contact and the contours are intersecting. When ideally speaking, what is this contours, what is this line, what is this points means, or what is this line means? This line means this is an inclined rock strata, and here I am going to cut this layer. Okay, then it intersects with a line. This is the line what I am considering here. And if you remember our structural chapter, the starting of the structural chapter, we discussed this. We discussed about this. What is this line called? If you remember, that line is called the strike line. Strike is the direction of a line of intersection between an inclined strata and an imaginary horizontal strata. This is an inclined strata and this is an imaginary horizontal strata. When they both of them intersect, the intersection which forms that direction of the line is called the strike line. So here in this case, the strike line is what which is showing the intersection. Why is it strike line? Because when I cut this rock strata at this particular height, then this layer, it is going to intersect, it is going to show this line. So that is what we call it as a strike line. So this strike lines what I am drawing here, this will have different values. Strike line what I am going to draw here, that will have a higher value. So if this is 30 meter, this is 80 meter, and this is 30 meter. It indicates when I cut an inclined rock strata at 30 meter, it becomes a strike line here. So that strike line gets a value of 30 meter. When I cut the rock strata at 80 meter, it creates an intersection or a line. Both of the lines are running parallel because both the rock strata is uniformly tipping. So if I climb equal distances upward, this is going to be parallel in nature. So this rock strata is a strike line at 80 meter. Okay, so that is the basic concept where we are going to use it for the geological cross section. In our case, if you see the geological map what we are having in our hand, here this is the rock strata of inclined bedded region, and here we have different layers. We have a rock layer A, we have a rock layer B, we have a rock layer C, and we have a rock layer D, and we have a rock layer E. And this dotted lines is indicating the contours. You need to prepare the topographical section of this area. That is the same method what we adopted in the previous map. So the topography will appear something like this. So after preparing the topography, we need to mark the lithological contacts. So to do that process, lithological contact, first thing is that to identify which layer I am going to consider. Okay, so all the layers we are not going to do in one stretch, because here there are having 5 different rock layers. For instance, it is 6 different rock layers. So I am not going to see these all 6 different rock layers together. Rather, I am going to see the contact between one layer, that is B and C. Okay, I am going to see it between the B and C. So if I see this contact, so this is the line of intersection between B and C, or C and C, or this is what we call it is the lithological contact between B and C. And if I look carefully, I can see this B and C intersecting the same contour at 300 here, and that same contour is cutting 300 here. Similarly, if I see this is cutting 330 here, so 330 here. And if you see again carefully, it cuts at 360 here and 360. So what I'm going to do, I'm going to mark these points 330, 330, and keep your ruler over that and draw a straight line. So this is how we get the geological map. So now you take the same paper strip and keep the paper strip over here and mark the point A, mark the point B, and mark this intersection where it is cross-cutting the strike line. What is the value of that cross-cutting strike line where it is intersecting? That value is 330. And what is the contact between these two? This is the contact between B and C. So I noted down that 330 is the value of strike line, and that marks the contact between B and C. Similarly, if I go to the next line, intersection that is cutting at 300, and that becomes a contact between B and C. Here 330, here it is 300, but the contact between B and C only what I am looking at. Now take this paper strip, keep the paper strip at 330 meter, plot the point, then take the paper strip and keep it at 300 meter, plot the point. Now you got 2 points. What you need to do? Join these 2 points using a scale. What we get? Or the layer B and layer C. So this is the contact between layer B and layer C. Similarly, I need to continue the process for other layers. So when I say the other layers, what I need to do, I need to identify the contact between C and D. So this is one point where it intersect. This is another point where it intersect. The value of this is 330, and it becomes C and B. So similarly, this is again intersecting. At least 2 points we need to draw the lines. So here it is again intersecting, and it is going to intersect somewhere outside, but we don't need that. We have 1, 2, 3 points to draw the contact between C and D. So similarly, take these 3 contacts and project it into the cross section. Then we will get another line which will be running parallel to the layer, something like this. So this is how the geological cross section of inclined strata is prepared.